Hi, this is Pat again. In this video, we're going to look at the Monty Hall simulation, the base code that you're going to use. Again, mine's in R. Feel free to use it, especially if you're going to continue on to the Intro to Statistical Learning course. You can say here, I based it on functions. So you're going to have a stay simulation and a switch simulation. So like you'd expect, if I stay with my original choice for the door, or if I switch and pick an alternate door. I'll walk through the code bit by bit, but you can see this is the initial function for the keeping the door, and I'll walk through these in just a second in a live setting. On the switch, this is the entire function for the switch. So you can see this one's called function change door, and this one's called function keep door. Once you have it set, notice the argument it takes is the trials. I guess when I had it set, I was testing 10,000 records, so we could see where the numbers came back. Again, our expected is 33.33 if we keep the door, and if we switch doors, we expect about 66.66. So 1 and 3 or 2 and 3. Then basically we're just going to go ahead and test it. And you can see here at the end, when you run them both, you will end up with basically the function runs for keep door for the amount of trials, in this case 10,000, ended up with 32.66. And here, when I change door, try 66.28. You notice these are not going to add up to 100 because they're both running separately. So they're independent samplings, so they're not doing a converse function. I'm not just running and saying, okay, take or compute all those 10,000 trials for staying at 32.66 and then just subtract from 100. I'm not trying to do that at all. So here I'm actually running two separate tests, and you don't even have to run them at the same time, which we'll look at here in just a second. So this is what will be published. This is what you'll see online, and you can start with. And again, what's nice is just like a Jupyter notebook, you can just copy and paste the code right into R or into another notebook, however you want to run it. Okay, so just to walk through those particular functions, here we are in this is the same page. This is just the knitter itself for the notebook. And what I want to do is actually show it before we run it. So first thing is on the keep door. What we basically do is you'll see the values down here. I'm going to set a counter to 0. So n's just going to keep count if they're successful for the keep door. Notice this is the entire function. This is where the trials, we would pumped in 10,000 in this particular case, or 1,000, whatever the number may be. First, it starts off inside the function and just sets these two. So these are the doors. So you can see it creates a vector of doors, door number 1, door number 2, door number 3. Right now there's 0, the counter's at 0 for how many was a match. I'm going to skip the for loop because I don't want to fly through it. I just want to go step by step so you can see what happens. So the first thing we do is we take a sample of the door and set it as the one where the car is. So in other words, the car is going to be behind door number 3. Now the contestant comes in and selects a door, any one of the 3 again. Remember, there's 3 doors, so I'm just doing a sample, which is just a random select door, and I'm only going to return 1. And notice they selected door number 2. So here, because this is the keep door function, it's going to say if the select door is equal to car door, then add 1 to the counter, which is currently at 0. And we know that's not going to change because they had car door 3, select door 2. So let's say it goes back through the trial again. When you add another one, car door this time is still 3. The select is 3. Looks like we're going to increment our n this time because select is the same as car door. So notice the n goes to a 1. At the very end, it takes the total count of the trials that you see here, takes the count of n divided by v trials. So again, a little bit faster than just clicking on the clicking on the online game we put together, but maybe not as much fun, but it's the exact same logic as in the game. So that is basically the function for keeping the door. To switch door, and again, if you want to convert this to another language, let's say you're a web developer and you want to do it in, Python, let's say, it's very easy to do. I'm just going to go ahead and reset all this. So the same thing here, we have a counter. This is if you change door. So again, it'll start at 0, and again, there's 3 doors, so nothing different there. Again, a car door is selected. So this time in this particular iteration, It's 1. Car doors, or the car is behind door number 1. Then we're going to do a select. Oh my gosh, we actually would have gotten that right, but not this time, because remember here we're going to be switching. So what happens on the remove is we're just going to do an if statement, and we're going to say if car door equals select. In this case it is, so we're going to do the first one. We're going to go into here and we're going to set the difference between door and car door. And you're going to see what happens on a set diff is it actually returns back a 2 and a 3. Because since they're the same, because we know we've actually picked it, but we're going to switch, then we're going to pick between 2 and 3. So we do a sample of 2 or 3. The sad thing is we've actually selected right the first time. So now our actual selection will be 3, and we're not going to win the car. So remove will basically, in this case, because it ran again, it picked 2 instead of 3. But either way, it's not the same car. So now the reselect, it just gets passed in, and you can see here, reselect 3, if car door equal reselect, and we're not going to have any luck on that because we had actually selected the right door originally. I'll clean those up. We'll run through one more time just by luck and see if it actually will work. Whoops, I need to actually set the N. I need to set the door. Here's car door. So I selected the car door 1, and I did it again. So we're going to start all over on that one because we want to actually see what happens if it goes to the if. So you can just see that, which in theory should happen more often, but so far not so much luck. So N is 0, door is 1, 2, 3. Car door, the car is behind door number 2. There we go, and the selection is 1. So this is where we're gonna have a chance at winning. So first off, we're gonna do a remove, if else, car door select, sample, set difference, etc. Same as before. So now they're not. So we're gonna go to this one. We're gonna go to door and car door select, and when we do a set diff, whoops, forgot to do the set diff. 1, 2, 1, 2, there it is. What it's going to do is it's going to bring back the other door. Because remember, they're not alike, so we have to get that third door, and that's how we capture it. So pretty straightforward in the way it does it. A little bit different in R, different in different languages, but it works fine. So I'm going to run that remove, and notice now when I run the remove, now I go back to my reselect, and it says if car door reselect. And does car door now equal reselect? I got 2 and 2. That's perfect. So now N will increment by 1. Because in that case, the change allowed us to actually win a car. And then you can see it work there. So that's how the functions work at a high level. And again, we can cover those in class as well before you get on the lab itself. When we're in the lab, we can go through any of the function pieces you need. Now to see how it works full on, I'm going to clear everything out, which I did. I'm going to come down to the code, and I'm just going to run this block of code. So this sets the function for stay. So now I've got a function called fKeepDoor. There it is in the trials, and if I want to look at the function, I can. It just shows me the function here in an R code. So it just breaks out the function so we can see it. So I'm going to close it here. I'm going to scroll on down to the next block of code. This is my change door, just like we walked through a minute ago. A little bit more complicated. We just have to take that extra step of the of reselecting the door. I'm going to run that function, and now it stores that function into the program, and it's live. So I've got change door, I've got keep door, and again, all this does is open up the code so you can actually see it in isolation in an R in a R window, so R code window. So now I'm going to come back to my notepad, and I'm going to fill my trials. So the first thing I'm going to do is I'm going to set it to that low number, just like we did when we were testing. So we were testing at 30. And when we tested at 30 was when we were actually clicking on the pictures, looking for the goats, first car, etc. So here we're going to run keep door. It's set at 30. And when I run keep door, notice my percent for win stay, 20%. We expect 33.3. And again, these are a very small amount of numbers. At this point, there's 30, 26.66, 30. So you can see each time I run it, it's doing a random select. It's going through that function of keep doors. And you can see I'm getting close to the 33.3, but not exactly. And this is the latest run right here, latest return. So what I'm going to do is I'm going to change this variable. I know those functions are already loaded. I can see them here in the application. This is where I'm going to do the 10,000. There we go. So I'm going to set trials now to 10,000. So instead of 30, now we should be getting closer to the line meeting the actual expected average. So here for keep door, I'm going to run that, and notice I get 32.81, very close to that 33.33 that was expected. Here's 33.26, and notice based on the history, 33.51, 33.33. Like you'd expect, you're getting a return very close to that expected average. With change doors, just like before, you should be expecting around 66.6. Here we get a 66.3, 67.2, 67. So you see, not graphical, just numeric, but a good base code for what you're going to be wanting to do and what you're going to be creating. So basically, you can take this and you're going to create a bit of a graphical return as well. So when you're running this, you may want to have a chart using ggplot or using any other type of charting engine you choose to use at this point. But I will have some more information for that online, and I will have this as well. So once you get this loaded up and running, then you can start editing and changing and decide what you want to do for your simulations themselves when you extend it.